Hello everyone, I'm Preshi from Hoax Games, and in this video tutorial I'm going to show you how to integrate Unity's animation rigging system with iStep. So what is animation rigging? This is basically a bunch of IK constraints delivered with the animation rigging package, and it can be used to do some IK transitions and stuff like that. So let's see what the end result is going to be. So we have here a character that walks around. It has an 2-point constraint for the right arm here to make the gun, to hold the gun. And if he goes near enough to this sphere, he's going to look at it with the head, with the body, and also with the weapon. And his left hand is using another IK constraint to make it in this weird pose. If I go away, it's also going away, so it moves like that. If I go up here, I can touch this thing in world space. So this is all done with very simple code. So actually all this is just one script, this activate constraint wait on enter that I have written to be used in this package, and everything else is iStep and the animation rigging package. So let's get started. The first thing you need is obviously you have to import iStep, and you also have to import the corresponding iStep demo content to have this character here. So I recommend to create a new project, import iStep there, a new empty project, import iStep there, import the demo there. Here I'm using the built-in render pipeline, and yeah, I haven't tested it with other pipelines, but it should be basically the same. So what you need as well is you need the animation rigging example project. The download link for this project, you can download everything that you see right now. You can download it from the description below, so that you can get the whole project and you can look at the code and how everything has been set up after this video or during this video. And what you also need is, of course, the animation rigging package. You can get the package from the package manager. Just set here Unity registry and select animation rigging and install this as well. Yeah, so these are the 4 things that we need, and now I'm going to explain you how this setup has been built together. So let's disable everything so we can go through all the content step for step. The plane obviously is just this grounding plane. The cube is the cube that you saw before here. This is set to UI so that only iStep collides with it, but not the collider. I'm going to show you that after that. So we have the lighting setup and these 3 things here. The main camera, the player follow camera, and the player imager. These are one-to-one from the iStep demo scene. I just dragged and dropped it from the demo scene to this scene and used it here. So actually it's the whole content from the demo scene, at least for the character controller itself. And yeah, so that's the base setup. Then let's open the player imager, because here I created this rig. The rig is just a component from the animation rigging package, so I just created an empty object in addition now to the player imager. So this rig wasn't here before in the demo, so this you have to add in case you want to do stuff like that. Add this rig component to it, and inside this rig we have all these constraints. So I'm going to disable them for now to show you every one of those and how it works together. But before we do that, or let's start with the, not the spine, let's start with the head constraint, because it's the most simple one. The head constraint is a head constraint. It's a multi-aim constraint actually, but I called it here head aim constraint because it aims for the head. So I have set up here the constraint object, the head. The multi-aim constraint, by the way, is also a component from the animation rigging package that you get when you install the animation rigging package. So I set the head as target here. The rest is, I think, completely default. And I have a source object, which is this corrected position. So let's enable this object. So what is that? This is actually our target object, the aim target. And this aim target has, in addition, this corrected target. And the reason for that is, I'm going to show you. It's iStep, because iStep, you have to know that it adapts for the position. So let's see what I mean by that. So if I go down here, let's split this in two and select the character. So if you look at that, if I go from left to right, you see that the capsule is always on the ground, but the player goes upwards. And this is due to iStep, because it adapts the body position as well to have a perfect alignment. And in iStep, I mean, everyone that has bought it already and used it knows that you can set up layers with which iStep collides in here. And one of those layers is the one from the cube, which is the UI layer, and this UI layer in this case doesn't collide with the character controller, and that's why the character only collides with the ground, staying on the ground, while iStep makes the player adapt perfectly to other objects also displaced where you don't want collision with your character controller. Of course, we can change this behavior, like saying we want this cube also to collide with the character controller. But here for purposing, for the displaying purpose and explaining purpose, I'm not going to do that. So this is the setup for this tutorial. And yeah, like you see, the height of the player or of the character is different from the capsule if it goes up this cube, and this is why this offset has to be corrected. And to do that, we are basically using this corrected target here. So the basic setup, usually if you want to look at something, it is you have your target like you usually have. If you don't use iStep, you actually would set up this aim target in here as the source, okay? But because we are of course using iStep and it adapts the body position, we have to make sure that we use the corrected target, which has to be a child of the target, okay? The setup for creating such a corrected target is you have your base target, this one, you create an empty child, everything 0, 0, 0, and in this empty child you add the global IK target connector script. This script comes with iStep, so it's in here. You get it when you import iStep, so you can always use it. This is a new feature of iStep, or a new script where it's designed to work with animation rigging, and you can also use it for other custom IK solutions where you want to correct the positions that iStep modifies. So in here, we added this global IK target corrector. We set the foot IK as the target, so this can be drag and dropped in here. The update method is update. You can use other update methods as well if you see fit for your own custom IK solution. And we also negated it. The reason for that, why we negated it, is because everything from animation rigging is executed before iStep makes the corrections, which means the character is actually on the ground. He is not on the cube when he starts looking at the target, and therefore you need a negated offset applied to the target that you look at. And this is actually exactly what this script here does. If we take a closer look here, So this is the real position that we want to look at, and our target, it's below. So it's the negated offset that the player has in here through the adaptation of iStep's foot IK script. So this should be clear, I hope. If not, there's a manual as well where you can read everything in addition. So that's basically how this works for the targets. So let's move on. This is how we make this look to the correct position, even though our body height is being adapted. This laser beam that you see here, this is just for debugging purposes. It's just a cube scaled and parented, so we know that we are exactly looking inside of the target. So let's move on. The same I did also for the spine aim constraint. So we have two constraints, one for the head, one for the spine, which is basically the same. But instead I selected the spine, I set a different weight, but I think everything else, it's almost the same. The constraint axes are also different. So it has different constraints for the axis. So the player will have some nice look at behavior at this sphere. All right, so let's move on. The next is something that works a little bit different, which is a two-bone IK constraint. You can set stuff like that. Let's remove the weapon. The thing is, I also have a weapon in here, so let's remove it for now, so we only see what we need. So this two-bone IK constraint can be set up actually fairly easy. You just drag and drop the tip in here from your hand, which is your hand. Okay, you can right click the two-bone IK constraint and press auto setup from tip transform, and then it fills all the content that you have in here automatically, which is nice. You can also always manipulate this stuff yourself, but it's nice to have if you can do this automatically. So this is what I did as well to set this up. Let's disable the aim constraint as well. This is something different. I'm going to go to this afterwards. So you can ignore the aim constraint for now. Just concentrate on the two-bone IK constraint, which has a target and a hint target. So the target is in here. Here his arm should be, or his hand should be, and the hint should be somewhere here. So this is how I set this up. And for that, for this kind of setup, with the two-bone constraint that you want to constrain relative to your character, you do not need this corrected, this global IK target corrector. You don't need that because it's in a different space. It's in a relative space, and it works. I don't want to go too much into all these details why it works, but you see the hand, it's always moving like everything is one thing. This is the expected behavior. This would be the same behavior without iStep as well. So this is what we want to achieve, because we want to have compatibility with animation rigging and iStep, and we get this out of the box for such a solution. So if you look at that, you will see that how can he grab this target correctly if the target is somewhere else? So you see the target is down here, but his hand is here, so it's all relative. Because the thing is, you don't want, this is why it works out of the box, you don't want to grab on this position, which is on an absolute position like this. You want to grab on a relative position in this case, and this is why you don't need this offset applied, and this is why it works. Just to explain it a little bit better. But because this target is down here, if you want to have a weapon the weapon would be placed here. So this would be a problem. And to avoid that, we did the same setup here as well in addition, which is we created an empty child. Let's stop this for now. We created an empty child with everything at 0. We added this global IK target corrector script. We again set up our player in here, our food IK script in here. Update mode is the same, but instead of having this negated, we have this positive. It's not negated because we are here inside our character and not in global space. And this is why this has to be not negated, because everything we want, if the character moves up, we want these things to move up as well. So if we press play again, and if we select this, it's exactly on the hand position, while this is down here. So this moves it up again to the hand. And if you compare it to the aim target, for example, that we had here, it's negated, so it's downwards, okay? So that's the difference. Here we need it, because it's parented to the player, we need it upwards, so not negative. And if we activate the weapon now, it's going to be where we want it to be. All right, I hope you understand that. So let's move on. Next, I'm going to enable the weapon now, and I'm going to explain you the other constraints, which is this aim constraint. So I'm enabling this as well. Or maybe let's still keep the weapon disabled. We just enable this aim constraint. The aim constraint is not animation rigging constraint, it's a default Unity constraint. You can use the multi-aim constraint as well for this, but in my opinion, the aim constraint works much better for this kind of things, because you are able to manipulate objects way better. The thing is, if you want to change or to constrain joints from the character, you should use the animation rigging constraint, like the multi-aim constraint, like we used here and here. But in this case, we don't want to change any bones. Our target is a different one. It's exactly this component here. So this is not, this target is not a part of the rig, it's just a game object. This works like that. This aim constraint works on the object it's applied to, and we want to look at something with the, or we want to aim at something, and this is the source that has been set up here. So this is again the same, the corrected target that we want to look at. So let's see what this does. This should make the hand always point to the target. You see the hand, this hand here is always going to look at this target here. This is what this does, and this is what we wanted to achieve. And exactly this is what this does. And if we enable for, so first we look at something, which is this target, and we correct the position. We now enable the weapon, and this weapon also has an additional aim constraint to always point also with the weapon at the target, because there can be some offsets between your weapon and your hand. And to get rid of this offset and to not waste too much time for optimizing all your parameters, it's better to place this aim constraint directly to your weapon. And this also has a target, but in this case, we are not targeting the corrected target, but the aim target. And this is because the weapon is already position corrected thanks to the global IK target corrector. So because of that, this weapon is again a different space. So it's in the real world space now, global space, let's call it that. So we have to look at their real position. So if we press play now, the weapon is going to point exactly at the sphere, at our aim target. And it doesn't matter if you're on top of this. So let's take a look again. So you see the sphere is still on the plane, and our character has moved up this cube, and it's still pointing perfect. So this doesn't break anything. All right, that's actually the most difficult setup from all this. I did two other things here as well. Let's have a look at this one. This makes the character grab something in the world. Oh no, sorry, this is the other constraint. Sorry, this is the constraint that makes this arm, the left arm, just constrained. It just has a target, and that's basically it. Let's activate. If this is just to see for debugging, I did this just to debug, to see where the hand is, if everything is correct, and it is, because it's exactly on the cube. If it's corrected, it always grabs on that. So that's basically this. It's not really necessary to have that and that, but for debugging I added it. This is just the same constraint as before. It's a two-bone constraint set up for the left hand, and it has the positions placed here and here. So that's this. We also have this constraint here. This is set to 0 right now. So I'm going to show you that. This constraint. So let's put this to 1. He starts grabbing somewhere, and let's see where this is. We have here target, which is disabled. So let's activate this. So this is where the character grabs. Interesting that if it's disabled, it has this. No, it has correct behavior. Ah, I understand. He was pointing upwards before because this object was disabled. Therefore, this script here for correcting the target position was never executed, and that's why this had this weird movement when we started. So let's enable this from the start. What is that? This is where we want to grab. If you look at this, it's just again a target. In this hand, just a simple empty game object in world space. It's not parented to the character. It's similar to the aim target. So here also we have the global IK target corrector script. We have our foot IK drag and dropped here from the player. We have it negated as well. Late update, we don't need late update, so we can use update here as well. It doesn't really matter in this case, but you may have some cases where you want to use a different update method. And the cube is just for debugging purposes. So that's this setup here. Let's press play again and see what happens. So the script is at 0 now from the weight point of view. Sorry, I have to select this. It's at 0, so it doesn't do anything, but if it put it to 1, he starts grabbing to it, and he tries to hold this position. You see, and it's always the correct position, even if you are on the ground or if you are on top of the cube. He always tries to grab this point, and yeah, that's it. This is also a two-bone constraint, but in this case it's pointing to something that is outside of the player controller, outside of the rig, which is a global target basically, somewhere in the world with absolute position. And we also, in here, our target is also the corrected position target. Exactly the same as with the aim target, just used by a different constraint, this constraint here. And yeah, that's all the content for the animation rigging. But in addition, I added two other scripts here, this touch on enter. We can have a look at this script as well. It's activate constraint wait on enter. I use the same for everything here actually. It's a very simple script, so let's open it up. And you see it just says if the player enters, set the target weight to 1. If the player exits the trigger, sets it to 0, and everything that is set up will get the weight. And that's basically it. That's a script that I wrote for this demo or for this tutorial. And on this touch on enter, if we look what has been set up, it's actually only the left hand V1, which is the one that we made us grab to this cube here in world space. So if we have this enabled and we press play, he grabs on this cube, but he only grabs on this cube when we enter, when our character enters this collider in here. Let's activate the mesh renderer so you see where it is if you don't see it. So I placed the collider down here. If the character collides with it, he's going to grab it, and if we don't collide, he moves again to his previous IK. So that's basically it, and it works. You see it works. Just saying, because you saw all this weird hand movement and everything that happens if you touch it from a weird perspective. This is not a tutorial that creates something that you can directly use in a game. If you want to use it in your games, you have to make it work for your game, of course. This is only a tutorial to showcase what is possible, and I'm not doing too much coding here, just showing how to use all this stuff correctly with iStep and that we have compatibility. So you can always use iStep with animation rigging if you set up your setup right. So that's the touch on enter. We also have here another trigger. All right, this is also a trigger, and this trigger is the look at on enter trigger. It also has the same activate constraint, wait on enter, and in this case it adapts this 5 constraints. It changes the weight of all this. So let's press play and see what this does. So if we are here, we are looking at this ball, but if we go away, we go back to default, okay? So we are not looking at anything anymore. You see that everything is basically locally oriented to the player. But if you enter this trigger, it makes this hand movement for the left hand. The weapon points at the ball, and it looks also, the player also looks at the ball. And if we go here, he also grabs this thing on top. So yeah, that's basically it. That's what I decided to showcase in this example, and to show you that yeah, everything is compatible with iStep, and you only have to use, in addition, this global target correctors right on a child object. You always need a child object, don't forget that. So from your real target, always create the empty child where you apply this object to. All right, basically that's it for this video. I hope it helps you out if you want to set up animation rigging while using iStep at the same time. And yeah, I hope you liked this video, and until next time.